Okay, so this is Module 10, Smart Contracts, and this is Lecture 4, Tokenizing Assets with Blockchain. This is the table of contents. We are going to see tokenization, initial coin offerings, and IRC20 tokens. This is the Module 10, and it goes about the smart contracts. And after this module, we hope that you are able to understand and use smart contracts in your distributed applications. The learning objectives of this lesson are: first, define the concept of tokenization, see what can we tokenize, mainly fungible and non-fungible assets, and then define special tokens that are used for funding companies, and see the phenomena of ICOs, and finally see the standard, the IRC20 standard, and we will create our own IRC20 token. So let's start with tokenization. And tokenization is the process of representing some asset with a value in the blockchain that we call token. And a smart contract helps us with this task and allows us to list, change the owner of a token, and so on. And as I said, we can group the assets to tokenize in two big groups. The first group is fungible assets. A good is fungible when it can be exchanged for another identical good with equal value. The most familiar fungible goods are commodities. For example, I don't know, a liter of water is a liter of water, or a liter of oil, or whatever. 1 liter is 1 liter if it is of the same commodity. Then the idea is to use blockchain to represent these commodities, and then use a smart contract to which we can do transactions and then trade or exchange all these commodities in the form of tokenized, in a tokenized form. We're going to see an example in a few moments. And then we have non-fungible tokens. Non-fungible tokens are goods that are unique. For example, real estate, a big building is unique, or theft or art, for example, Mona Lisa is just something that is unique. And we can also represent unique things in the blockchain. Well, the idea is that we use different structures for fungible and non-fungible, for representing fungible and non-fungible assets. In this lesson in particular, we are going to focus more on the fungible assets. There are many uses for tokenization. It has I would say that is one of the main, if not the main, current application of blockchain. And the tokenization has a big amount of use cases. For example, it is used in the gaming industry to tokenize different aspects, or this new way of playing that is play to earn, for example. Or for example, we can tokenize attention. For example, BAT is tokenizing our attention, so we are tokenizing also intangible things. Or assurance, for example. We can have usage-based insurances, and we can store all the use all the contability of this can be tokenized, and we can use blockchain for that, or tokenization of energy, or many different things. But one of the main uses, in fact, was to use tokenization for funding companies and startups. And this is one of the first use cases. And this idea gives rise to the concept of initial coin offerings that are like the equivalent in blockchain of initial public offerings, IPOs, but in this case in blockchain. Essentially, it's just a way of funding companies. I mean, in the traditional funding of a company, essentially you are searching for investors, and typically the earlier that an investor joins, the higher the risk and the more expensive it becomes. I mean, it will ask for more shares on your company. Another option is to go to the stock market, but this is complicated for small companies. And then, it appeared this third way or fourth way of funding. Mainly at the beginning, it was not very. There was not so many regulation about this, and the idea is to use blockchain to get funded. Okay. As I said at the beginning, there was not many regulation on the area, on the field of ICOs, and there are like different scams and problems. For example, this one, Safe Droid, for example, was a company that raised 50 millions, and the founder just closed the closed the project and run away with the money. Let's see how to build an ICO. Essentially, an ICO has like two parts. One is one smart contract for selling the tokens. Essentially, it's a smart contract in which you send transactions with ethers, and then this one gives us tokens. And these tokens, in fact, are created or generated or issued, are minted, is the word that we typically use. They are minted in another smart contract that we are going to call the token ledger, because the token ledger contract is the contract that has all the contability. I mean, there you can see each address, how many tokens have, the balance. You can also use this smart contract to transfer your tokens to another account, and so on. Okay. In fact, when I said when I talk about the ERC20 standard, the ERC20 standard precisely defines this second smart contract and defines which functions must have this smart contract, and which functionality must have each of these functions. So, now let's try to code a little bit one simple ICO just to see how it works. And so let's build a simple ICO. Okay, I go back to our well-known remix. Okay, remember that we can build our smart contracts here in remix. And to see the mechanics of an ICO, the idea, remember, that is this is I'm going to create first it's a simple sale or token sale, but in this case I'm going to do just a single contract for everything. So it is a simple token sale and token ledger. But later we are going to see we are going to use the ERC20 as the token ledger. Okay, so let's see. let's see how to build a simple ICO. And the idea is that first we need all the storage. And let's say the storage for the sale. Then we are going to create some storage for the ledger, token ledger. And then we have the functions. Functions for also functions for the ledger, and also functions for the crowd sale. Let's say functions for the sale and functions for the token ledger. Okay, let's start with the sale process. And well, in this case, we're going to create a smart contract, and we're going to give to our users, we're going to give 10 tokens per way that they transfer to us. Remember that one way is 10 to minus 18. Okay, so 10 minus 18 ethers, this is one way. So so if you give me one ether, then I'm going to give you, I'm going to give you 10 tokens per way. If you give me one ether, that is 10 to the 18 ways, then I'm going to give you 10 times more, so 10 to 19 tokens, for example. Okay, this is the idea. So I give you 10 tokens per way, and we're going to sell 1,000 ethers. Okay, maybe, yeah, these slides, this should be 3, this should be to the 22, and so on. Okay, so we're going to create a smart contract to sell 1,000 ethers, and yeah, that's the idea. Okay, so let's see what we need to build this, or let's build this this smart contract. And we're going to create some variables here. Everything is going to be integers without sign for this smart contract. We only need positive numbers here to describe all our situation, which is the sale and the ledger of the tokens. And the total supply of tokens that we want to sell is 10 to the 22. Okay, so this is going to be 1,000 ethers. And this is because we are going to do a token swap of 10. This means that I'm going to give you 10 tokens per way. So this means that yeah, this is 1,000 ethers. Okay, and in another variable, I'm going to record, or I want to store how many tokens I have sold. Okay, so this is the we're going to call this the supply, and this is the amount of tokens sold. Okay, that's all. That's all that I need to do the selling uh, of our ICO. Uh, so, well, let's build one function here. For example, and the main function here is obviously is a function to buy tokens, right? So let's call it buy tokens. And this function is going to be external. Means that we can call this function with a transaction, and payable means that we can send ether to this function. Okay. And what I'm going to do here is to first, I'm going to check, when I receive a transaction to this function, I'm going to check with a require, I'm going to check how many ways are you sending to me. And if you send me, in message value, we have the amount of ways that we are receiving in a transaction. If we multiply this by the token swap, then I get how many tokens do I need to deliver, would I need to send you. And then if I add here the supply, which is the current number of tokens that I have already sell, then this should be smaller than the total supply. I can I cannot send more than this. This is what I am encoding here. Obviously, this is just one. This is just to practice. Okay, but you can decide the logic that you want. But in general, selling contracts, selling tokens have this idea of putting a total supply or a maximum supply. Okay, so if I have enough tokens for you, then I compute the amount of tokens. Let's say you int 256. Let's define tokens amount. And yeah, this is the amount of tokens that I need to give you, is this one here. And then the idea is that this smart contract is going to record, it is going to be the ledger also of these tokens. It's going to provide me all the information about who owns which tokens and so on. So to do this, I need to store the amount of tokens that each account has on this system. Okay, so here, because if you buy and I have enough tokens, now I'm going to assign your tokens to you. Okay, but to do this, I need to define here a structure to store the tokens. And typically this is done in a mapping, which is, again, is a key value on each address will point to a integer, to a positive number, to a unsigned integer. Let's call this balance, for example. And then what I do here is just to store in the balance. I increase the balance of the the account sending the transaction. Okay. I say that this is equal to, or you can do plus equal, or let's do it equal. I say that the balance of this is the previous balance plus this token amount that I am sending now. Well, this is, for example, one small piece of this smart contract. In the slides, and also you have more information, okay, but and you have more functions that you could do, but this is essentially the idea. Okay, so this is the idea of tokens. You need some smart contract or some way of selling the tokens, maybe I don't know, any external way, and then we have like several functions to for the token ledger. For example, one of the functions here could be the balance. Just return the balance of the smart contract, for example. Well, this is putting here public. Essentially, I'm creating a function that returns the balance. So, okay, let's test this small smart contract. And we will go to see how IRC20 works and which are the functions that are really used in practice for the ledger token. But before, let's deploy this smart contract. Okay, let me deploy the smart contract, for example, from this address. So I deploy this smart contract. And now we will see how to send Ether to this smart contract and see that we receive tokens in exchange. So now you see here that buy tokens is in red. This means that you can send ways. You can send money to this function. And for example, let's send 400 ways. Okay, to this function, I send these 400 ways, and then you can check the balance. We can check the balance of this account, just copying here, and I paste it here in the balance, and check the balance and see we have 400, but since we get 10 tokens per way, we have 4,000 tokens. Okay. The total supply that we are going to deliver is this one, and the supply is because I didn't finish the code. Okay, after I increase the amount here, I should also increase, obviously. Well, it should be continued. Okay. But obviously here you should take the supply and say that this is the previous supply minus the amount that I just assigned it to the message sender. Sorry. Well, and so on. Okay, let's discuss this. Let's not program everything, but let's discuss it over the slides. Okay, so okay, this is the explanation here. Well, in the slides it is a little bit more complex or organized. Okay, but as I said, we should subtract the supply, and well, we have some conditions to check, and so on. Okay, but yeah, you can take a look at this code, try to see if you understand the idea, see the different parts, see the ICO for selling, well, see the part that is selling the tokens, and then the other part that is just, keeping all the token ledger. Okay. In fact, I haven't developed too much the token ledger, as you see here. Okay, it's just a couple of functions. Maybe I should implement some transfer of the token and so on. But it is not really worth, because there is a standard for specifically delivering with the token ledger, and this standard is the IRC20 standard, and this is the IRC20 is the standard for IRC20 tokens. And if we see a smart contract or an IRC20 smart contract, we will see that we have the storage, which is the main part here. We see that there is a mapping, okay, between each account and the number of tokens that we have. Okay, so this is what we are, the same structure that I used. Okay, it's a mapping. The main structure of an IRC20, the main storage structure, is a mapping that goes from each address to a unsigned integer of 256 bits, meaning that for each address we have the amount of tokens that belong to this address. So, as I said, this standard IRC20 is for fungible tokens, and yeah, you can check the standard there. And essentially, the standards, Ethereum standards, many of them don't define exactly the functionality. I mean, they don't provide us the implementation of the functionality. They just define the name of the function, the interface. I mean, which functions our smart contract needs to have, and how many arguments need each function, what they do return, and so on. Okay, but not exactly how they are implemented, so that people from the Ethereum is leaving room for different implementations. Okay, so if you take a look at the IRC20 standard, you will see that this is the functions that are defined there. Okay, so there is one function that is transfer. Okay, this is very clear. It's essentially transfer my tokens to this address and the amount of tokens that I want to transfer to this address. Okay, balance of, well, it's a function that is view. Okay, it's just to check how many tokens do I have. The total supply, just to see which is the total supply of tokens. And more or less that's it. I mean, probably these functions were expected, but it is not very complex. The IRC, in fact, is quite simple, the IRC20 standard. And the only special functionality that maybe you didn't expect is that it has an approve mechanism. What does it mean? It means that you are the owner of some tokens, then you can approve, you can send a transaction to the smart contract and approve to an spender. And then this spender can spend the amount of tokens that you approve. And the spender can transfer tokens on our behalf, let's say, okay, to a destination here. So in this for this approve mechanism, we have this function approve, and you put here the address of the spender and then the amount of tokens that you want to approve. And then when you want to transfer, if you are the spender now and you want to transfer, you need to use this other function that we call transfer from. Okay, the function allowance tells us how many tokens are we allowed to transfer. Okay, well, this is quite a simple mechanism. Despite that, well, it has some security issues too, or it has I also recommend you that you take a look at all the security problems that IRC20 standard has. Okay, but yeah, now in this class, we just want to go with the basics. So let's just see in more detail let's see an example of the approve mechanism, and then let's deploy a smart contract with let's deploy a smart contract, IRC20 token smart contract, and play a little bit, and that will be all. Okay, so in this case, how the approve mechanism works. I mean, if you do a direct transfer, essentially you are this account, and you just put here the destination of your tokens, and here you are transferring K tokens to the account 0xD. 0xD or 0xe representing generic accounts of Ethereum. Okay, how can we do this with the approve mechanism? Well, in this case, you are this account here, and you are here. If you call approve, providing an address and an amount of tokens, essentially you are approving that 0xC, in this case, can spend up to K tokens on your behalf. And the idea then is that later this account 0xC can send a transaction to the smart contract or with the token ledger, the IRC20 token ledger, and can say, okay, I want to spend from this account 0xe K prime tokens, another amount of tokens. Obviously, K prime needs to be less than K. I mean, this is going to account how many tokens are you spending, and you cannot spend more tokens than K. So, and then you put a destination here. Okay, so this is the idea. Okay, so let's test this approve mechanism with an implementation. And the idea is that instead of implementing ourselves this contract, we are going to use a smart contract programmed by other people. In this case, we are going to use the implementation, very well-known implementation in Ethereum, that is by the people of OpenZeppelin. So let me create here another file, let's say my token. And let me copy the two first lines here. And then you can use code from other from other teams just with the import, okay? And so Remix knows how to add OpenZeppelin I mean, Remix knows how to go to the contracts of OpenZeppelin. And here is the path to this. Okay. In fact, when I'm saying when I'm using this, I'm using here. Yeah, I'm using here at npm. Well, it is searching. This is like a package. This is a package with this smart contract. Okay, we can see the code here of this smart contract here. Okay. So if you are curious and you want to see professional implementation, you can take a look. Okay. In this case, I just want to use it. So I want to show you that it's easy to use code from another provider. Okay. And it's as simple as importing the code. Okay. With this line here, we are importing the code here. And then we just create a contract, and let's say my token. And then we are using the code of IRC20 from OpenZeppelin. And yeah, we can set up some parameters here. The constructor is used to, well, it's executed once when the smart contract is deployed, and it is used to set some initial parameters. And we're going to set the initial supply. I mean, this is when we deploy the smart contract, we are going to be able to select the initial supply. Okay. Well, this is an IRC20 smart contract with my token. These are parameters of the IRC20. Let me check here. Yeah, this is not very exhaustive about Solidity. Solidity is long to learn, but yeah, some ideas. Let's see here. You see, when we are constructing this IRC20 smart contract, he's asking for a name and a symbol. Okay, and this is what I am providing here: a name and a symbol. Okay, don't worry too much about programming this. It's just using this, and then this smart contract has a function that is called mint that is able to create tokens. And okay, and let's send all these tokens to the one that is sending this transaction, that is deploying this smart contract. And we're going to mint. The initial supply will belong completely to the one that's deploying this smart contract. Okay, so we only have like the import and 3 lines of code. It's just using the smart contract, the ERC20 smart contract from another provider, and we are just doing some small tweaks here just to put a name and a symbol to our smart contract, and then just we are accepting in this smart contract, we are accepting a parameter when we deploy the smart contract and assigning all the tokens to this message sender. Okay, let's test this smart contract, and we will see that it works. Let me check here. Okay, okay, let's deploy the smart contract. Well, let me delete everything. So the owner of the smart contract is going to be 5v3, Okay, let's deploy the smart contract. And now to deploy the smart contract, it's asking me the initial supply. How many tokens do I want to create? I don't know. 5,000, I don't know. Okay, let's deploy the smart contract. And if I see here, I see all the functions that I didn't program this time because I'm using the implementation of a third party like OpenZeppelin. But well, all these are like functions from the ERC20. And then let's see the balance. Let's check. Let's copy this account. Let's go here and see the balance of this account. It should have all the tokens, the 5,000 tokens. Okay, it has all the tokens. Obviously, I can transfer to another account. Let's say to AB8. Okay, let me copy. Again, I go back again to 5B8, which is the owner of the tokens right now, and then transfer to, and here I can transfer to this account. I'm going to transfer 1,000. Okay, let me transact. If I check again the balance of this, now it's only 4,000 because we transfer 1,000 to another account. Okay. And then to finish, I just want to check the approval mechanism. That is, I'm going to approve. Let's approve this one, this address here, 878. Okay. Let me copy this address. And okay. Here I'm going to approve to this 787. I'm going to approve that it can spend 1,500 tokens on my behalf. Okay, obviously I need to be the owner of the tokens to approve. Okay, so I select again the account that is the owner of the tokens, and then I approve. Okay. And now, well, we can see the allowance. I can see this account. Let me check. So the allowance tells us in the name on behalf of 5B3, this account 787. How many tokens can spend? Let's see, and it says that 1,500. That is just the amount that I selected. And now let's transact from this account, from this allowed address. And the idea then is select this one here and see that it can transfer on behalf of the 5B3 account. Okay, so we finish with this transfer from, and let's see. Okay, from address must be 5B3. Let me copy from this 5B3. I want to transfer 500 tokens. 500 tokens to some address, to, I don't know, to this one, 17F. Okay. So I'm going to send this transaction, but this transaction is going to be sent from 7A7, which was approved to spend on behalf of 5B3. Okay, so now let's simply transfer from. I transact, and it went okay. And to finish, just see to this address, and let's check that this address has 500 tokens. And okay, that's perfect. Okay, well, I played a little bit, maybe a little bit fast. Maybe you can do it slowly and test it by yourself. In this case, well, we finished the module by providing some, well, to see how to use smart contracts done by other people and essentially use them. Okay, you don't need to program them, you just need to know how they work and use what is available. And this is a general rule also. Smart contracts are delicate. It's easy to it is easy to make mistakes and reuse code as much as you can. I mean, use the smart contract, the already programmed smart contracts that are available and audited and so on. Try not to reinvent the wheel, because programming smart contract is prone to errors, and the best way always is to use something that is already there and it has been tested and audited. So, well, this concludes the module, and thank you so much. See you in the future.